Today I'm going to be demonstrating experiment 9.2, measuring the coefficient of volume expansion for a gas. So for this experiment you're going to need a round balloon, a thermometer, some string, scissors, a ruler, and some tape. Alright, so the first thing I did was I blew up the balloon, and the next step was to take some string and wrap it around the center of the balloon to find its circumference, and then cut it to that exact length, and that would be this right here. Alright, so once I found the length of the circumference of the balloon, I taped down my string in a few places so that it wouldn't move. And the next thing I'm going to do is I'm going to take the balloon and I'm going to go ahead and put it in a freezer for an hour. Alright, so I just took the thermometer out of the freezer, and the temperature is about -10 degrees. Alright, so I went ahead and took the balloon out of the freezer, and I measured the difference in circumference from when the balloon was in normal room temperature and when the balloon was in the freezer, and you can see that distance here is the difference in circumference. So that brings us to the equations part of this experiment, and the first thing we did was to find the circumference of the room temperature balloon, and that was done by just measuring the length of the entire piece of string, and found to be 56 centimeters. Then we measured the amount by which the circumference decreased by measuring that part from where I marked to the end of the string, which was 4 centimeters. Subtracting the 4 centimeters from the 56 centimeters gave us the circumference of the cold balloon, which came out to be 52 centimeters. So the next step was to find the radius of both the room temperature balloon and of the cold balloon, and this was done by using the formula circumference equals 2 pi r. Since we were given the circumference and 2 and pi, we were able to solve for r. Doing so for the room temperature balloon gave us 56 centimeters divided by 2 pi, which gave us a radius of 8.9 centimeters. Doing the same for the cold balloon with the given 52 centimeter circumference divided by 2 pi gave us a radius of 8.3 centimeters. After this, we found the volume of both the room temperature balloon and of the cold balloon by using the formula V equals 4/3 pi times r cubed. For the room temperature balloon, we multiplied 4/3 by pi by 8.9 centimeters cubed, giving us a result of 2,953 cubic centimeters. For the volume of the cold balloon, we multiplied 4/3 by pi by 8.3 centimeters cubed, giving us a result of 2,395 cubic centimeters. When we subtracted the volume of the room temperature balloon from the volume of the cold balloon, that gave us a result of -558 cubic centimeters, which was equal to delta V. The next thing we did was to find delta T, and to do that we took the room temperature and subtracted that from the temperature of the freezer, which gave me a result of -31 degrees Celsius. After doing that, we went to plug the numbers that we had into equation 9.7, noticing that V sub O was the volume before the temperature changed, and in our case that would be the volume of the balloon at room temperature. Plugging our numbers into equation 9.7 gave us a result of -558 cubic centimeters is equal to beta multiplied by 2,953 cubic centimeters times -31 degrees Celsius. When we solved for beta, that gave us a result of 0.00610, which is the coefficient of volume expansion.